Okei. Elikkä miten ilmasto on muuttunut? Miten ilmasto on muuttunut muinoin? Elikkä, vai minkälainen ilmasto on ollut? How the climate has changed over time. It has. Elikkä niin kuin mä aikaisemmin sanoin, niin joskus on ollut niin, että maapallo on ollut ihan sellainen oikein kuuma paikka, niin että meret ei nyt ihan kiehunut, mutta meret on ollut tosi lämpimiä. Että siitä, että se tiedetään meressä olevien niin kuin kivien koostumuksesta, että mitä siellä on tapahtunut joskus kauan sitten. Me tiedetään merien kivien mineraalikoostumuksesta, että siellä on ollut todella kuuma joskus. So we know from the rocks in the sea that the oceans have been very warm million and hundreds of millions years ago. So actually it's quite amazing what we know and how we know it. At the same time, this climate change and climate thing is at the same time it's amazing example of science. So it's a very exciting thing and it's a very scary thing at the same time. So, but because of this problem, climate change problem, global warming problem, we know now lots of more about Earth history and climate and things like that. And one thing we know that the climate was very warm in the ancient times. This graph of temperature of the planet Earth. Here it goes to Cambry area, 500 million years ago, before present. Okay, this 2,000 years, not much. But the climate was the average temperature of the globe of the Earth was about 30 degrees. So now it's 50. So it was very hot then, and there were no ice on Earth at the warmest time. So the both poles were without ice, and there were crocodiles on the southern area and so on, and the northern area, etc. And there have been colder times too. On ollut kylmempiä aikoja ja on ollut maapallo ollut jäässä, mutta sitten on ollut aikoja, jolloin maapallolla ei ollut yhtään jäätä. Sitten on tämä paleoseeni, eoseeni aika. Tuossa muistetaan 65 miljoonaa vuotta sitten tuli semmoinen pieni kivi tuolta taivaalta ja dinosaurukset kuoli. The dinosaurs gone. 65 million years ago about the climate a little bit cooled down a bit, but after it there was a huge volcano era and CO2 amount in the atmosphere of CO2 raised to about of course these are not exact figures and we don't know exactly, but it might have been 1,000 to 2,000 parts per million there. Eli se CO2-määrät tuossa paleoseeni, eoseeni aikana, niin ne nousi sinne 1000, ehkä 2000 ppm, eli nykyisestä sitten kaksin tai ei kun nelinkertaisesti tai kahdeksankertaisesti. So 4 times to 8 times more than now. So the Earth was much more warmer than today. It was about 14 14 degrees warmer. So that would mean that if Finland would warm, this area would warm 14 degrees, we would be southern Spain. So we'd be just the southernmost Andalusia, we would be there. It's about 20 degrees Celsius, the average temperature in Andalusia. So actually the same temperature, if you want to know the average temperature of one area, you drill a hole, you make a well, teet kaivon ja mittaat sen veden lämpötilaa. Se on se vuoden keskilämpötila. Or if you go to a cave, menet johonkin luolaan. Go to a cave in Andalusia and you measure the temperature. That's the average temperature of that area for the whole year. Quite exactly. Andalusiassa se on 20 astetta. Ilman, kun siellä on mukavaa olla luolassa siellä asua. Se on 20 asteen lämpötila. But okay. And the Earth has been cooling down little by little after the Petton, Paleocene, Eocene era. And the atmosphere, the CO2 in the atmosphere has gone down all the way. And when there has been a lot of CO2 in the atmosphere, it's mainly due to volcanoes. Because volcanoes are the thing that gives us back the CO2. If there wouldn't be volcanoes, we would be dead in few million years, of course. But we need those volcanoes to get us the CO back, because okay, plants need CO2. The whole life cycle needs CO2. But it has why this temperature has gone down and why the CO2 has gone down. It's mainly because their continents are in a such position that the CO2 will erode. It will go to the sea bottom, and the continents are in that position that there are not so big eruptions, volcanoes. But in the future, after a few 100 million years, the continents will again be in that kind of position that there will be huge eruptions. But not now. So it has gone in many million years. The last 50 million years ago, it has gone down and gone down. Okay, here there are different scales. Here are 100 millions, here are 10 millions, here are millions, and here are 100,000 years. Eli me ollaan tultu nyt täältä alaspäin sieltä 50 miljoonaa vuotta sitten. CO2, hiilidioksidi on ilmakehässä vähentynyt, ei ole ollut suuria tulivuoren purkauksia ja ilmasto on myös viilentynyt. Mä kerron kohta, mistä me tiedetään nämä lämpöt, mistä me voidaan ihmeessä tietää näitä lämpötiloja. I will tell just a little bit about how we know about the temperature in the ancient times. Ja sitten tullaan tänne satojen tuhansiin vuosiin ja lämpötilat. Tässä on jääkausisykli. Jääkaudet alkoi sieltä noin 2 miljoonaa vuotta sitten, kun Panaman kanava meni kiinni. Muun muassa se vaikuttaa sitten siihen, että lämpötila ei lämmintä virtausta ei tule niin paljon tänne pohjoiseen ja sitten alkoi nämä jääkaudet. About 2 million years ago, the Himalayas were high and they were eroding, they were capturing the CO2, and Panama Canal, Panama was closed so that the ocean currents didn't warm the northern hemisphere so much, and then started the ice ages. This cycle started. And can show you this. This is the 800,000 years which have been drilled from Vostok area in South Pole, Etelämantereelta, porattu jäätä ja saatu selville, että kuinka paljon sitä hiilidioksidia oli ilmakehässä eri aikoina, kun sinne jää pieniin kupliin. Siinä jäässä on pieniä kuplia, small bubbles in the ice, so you can measure the CO2 in those bubbles. And we can see here, it's about 180 parts per million when it's at the lowest, and when it's the highest, it's about 280 parts per million when the CO2 is at the highest. And you can see it's very steady. It doesn't go below 170, and it doesn't go up actually more. It doesn't go over 300 parts per million. So it's quite steady. The amount in the atmosphere varies from 180 to 280 all the time during those let's say million years. Elikkä se ei nouse sen 108 tai juurikaan alle 180 alle 170 ppm eikä se oikeastaan mene yli 300 ppm. Eli käytännössä se on siellä 280 korkeimmillaan 280 ppm ilmakehä, se on CO2. CO2 on toi punainen, toi metaani on toi vihreä. Okay, this is just CO2. How do we know how it impacts on the temperature? I don't have it here. It would take me just a few minutes to find it, but this is the most amazing thing, I think. One of the most amazing things is that oxygen has two isotopes that we can measure. It has oxygen 16 and oxygen 18. Eli tässä on kaksi hapen isotooppia, joilla on siis eri määrä tavaraa siellä ytimessä. Ja me pystytään analysoimaan nämä hapen isotoopit. Eli tämä on painavampi, siellä on enemmän tavaraa. Eli happi 18 on painavampi. Ja nyt meren pohjasta pystytään tutkimaan näiden hapen isotooppien määrät, suhteet. In the sea bottom you can measure these isotopes, the relative amount of those. How much there is 16, how much there is oxygen 18. And this is the heavier one. When it's cold, when the temperature, when there's ice age, when the temperature is cold, more of this stays in the pentic, in the bottom. Eli kun on kylmempi, niin tämän osuus on suurempi siellä meren sedimenteissä kuin silloin kun on lämpimämpi. Koska silloin kun on lämpimämpi, niin se haihtuu myös helpommin. Ajattelette, että se on painavaa, jos on kylmä, niin se ei haihdu niin helposti. Jos on lämmintä, niin se 18 haihtuu enemmän. So, when they have drilled the the ocean bottom, they can say what kind of temperature there is just measuring these oxygen isotopes. And they match totally perfect those CO2 amounts in the atmosphere. And these are measured, I'm not sure if they are measured from the ice too. I think they are measured from the ice, drilling of the ice too. from the sea bottom and from the ice. I'm not totally sure about the latter one, but I think it was so. So okay, anyway, so this I think they have really found an amazing stuff, amazing proof of Asian climate change. Okay, so why? The question is why there are times when the climate is colder. Why? Why has this happened? Why is this? And the reason is Milankovitch cycles, which is that the Earth is going around Sun in different angle and in different distance from the Sun. It has actually at least three or four different cycles, and when the cycles are optimum for climate in Earth on Earth, when they are optimum during Nordic summer, the climate is warm, and when they are not optimum for the Nordic summer, the climate is cold, so it will be ice age. Elikkä se on ne Milankovitchin jaksot, on maapallo se on vähän kallellaan, sitten se kiertää aurinkoa vähän kauempana tai lähempänä. Silloin kun nämä kaikki asiat on niin, että se on optimaalista pohjoisen kesän kannalta, niin silloin on lämmintä, ja sitten kun se on kaikki ne kolme jaksoa on epäoptimaalisia sen Pohjolan kesän kannalta, niin silloin tulee jäätikkö. Elikkä se on niinku laukaisija on se Milankovitchin jakso, ja se johtaa sitten sen ilmaston kylmenemiseen tai sitten se johtaa takaisin lämpenemiseen. Okei. Mä en lähde sitä sen enempää nyt selittämään enkä perustelemaan, mutta ne tiedetään, että ne on ne Milankovitchin jaksot. Elikkä käytännössä me lähtee vähän lämpenemään ja sitten se CO2 alkaa nousta perässä, eli CO2 ilmakehässä alkaa nousemaan, kun se Milankovitchin jakso alkaa lämmittää. Ja sitten se CO2 eli hiilidioksidi ja vesihöyry lämmittää sitten vielä entistä enemmän. Elikkä
tiedäänkö me, että millä jaksolla me nyt ollaan, että mihin suuntaan se on menossa?
Mä oon lukenut siitä vähän erilaisia arvioita, että mulla ei ole tässä sitä nyt tässä, mutta me ollaan ilmeisesti menossa kylmempään jaksoon. Elikkä jonkinlaiseen kylmenemisjaksoon, mutta oltaisiko me oltu menossa jäätiköitymiseen, niin siitä en ole ihan varma. Et mun mielestä mikään Milankovitchin jakso taas ei ollut niinku selkeästi, että ne olisi jääkausi tulossa just nyt. Et niin se ei ole. So the question was were we naturally going to the colder period because of the Milankovitch cycles, and I think if I remembered right, we were not going to ice age toward ice age, but we were going to colder period, but not towards ice age immediately. But as you can see from here, these are the warm periods, these hilltops here. They are relatively short. The last warm period was here, last interglacial, they are called interglaciaali, eli lämmin jakso. Ne on hyvin lyhyitä. They would last only 10,000 years maximum. And now we have been during this warm period 10,000 years. So we would have gone down. Perhaps after 5,000 years, after 10,000 years. Nobody knows exactly, I think, yet. But anyway, the cycle would have continued. The ice age, glacial period, interglacial, eli lämmin kausi, kylmä kausi. Okay. There is one person, one scientist, actually oceanographer, David Archer, in this book, The Long Thaw, pitkä sulaminen. He says in this book, evaluates that the warming period, we will skip at least one ice age, or perhaps two, because of this warming. It would mean that we won't do this cycle for a while. We continue. It would be a steady warm, without ice ages. Perhaps the next 400,000 years. It's quite amazing. I have made a evaluation of this book in Finnish, actually. Okay, about history. But anyway, we are in an era of unprecedented change, ennennäkemättömän muutoksen edessä. Koskaan ihmisen historiassa ei ole ollut tällaista jaksoa. Never in human history, human prehistory, there has been times like this. The times are really changing. And actually, not even in the history of our ancestors, of Homo species, Homo genus. We have to go back really when the humans were just evolving from Australopithecus afarensis. So we have to go this 3 million years go back. So we don't know how we can adapt to the new climate. Really, it's just a puzzle for us now. Me ei yhtään tiedetä. Meidän pitää mennä 3 miljoonaa vuotta taaksepäin, että me saavutetaan semmoinen ilmasto, mikä nyt tulee olemaan ja mikä silloin 3 miljoonaa vuotta sitten oli. Että se on täysin arvoitus. Ja sitten kun me tiedetään, että meillä on moderni yhteiskunta, ihmiset asuu meren rannalla, moderneissa yhteiskunnissa on riippuvaisia maanviljelyksestä ja niin edespäin, niin tämä on kyllä todella tulee olemaan erikoinen, täysin niin kuin ennen kokematon. Okei. How do we impact on climate? Okay. First, I show you some web pages where you can watch what's happening. Where you can check what is the temperature, what is the amount of CO2 today, and so on. I show you some web pages. Just try to find. I have lost some pages, I think. They are here. Okay, Keeling curve. Keeling started this measuring of the CO2 in the atmosphere back in the 1960s. or actually 58. Yeah. And see, here you can see it had already gone up from this 280 ppm parts per million over 300, and now it's over 400. So here you can see, here is the breathing of the earth. During winter time, the CO2, the earth is exhaling, hengittää ulos hiilidioksidia. During summer, Nordic summer, it captures the CO2. Se ottaa siihen sisään. Tässä nähdään maapallon hengitys tavallaan. Tässä nähdään, että se nousee syksyllä, talvia kohti, keväällä se on tähän aikaan korkeimmillaan, sitten se alkaa ilmakehässä laskea, kun kasvit sitoo hiilidioksidia. Because most of the land area is up here, north. So most of the land area is Eurasia. So most of the land is on the northern hemisphere. And when it's summer here, the plant will capture the CO2. So in the atmosphere it goes down during our summer. That's the way. And in 1 year you can see 6 months, 1 month, 1 week. But you can see and you can say full record, and here you can see the from 17th to 18th century. This is a record from ice core, I think. Yeah, ice core data, and it has been this 280, and now it's going up because of we are burning coal, oil, natural gas. We have agriculture that is releasing greenhouse gases, and we have land use. Different kind of things. We pollute the atmosphere. This is 2,000 years. The rest 2,000 years from ice core, and this is 10,000 years after ice age. So it has been very steady, and now it's peaking, rocketing up the CO2. Okay, killing curve. That's one thing you should look at. Watch it up in a while. Okay, this is no news. It's going up. No news. Sitten on tämä NASAn satelliittimittaukset, eli lämpötilaa voidaan mitata mittareilla, maan pinnalla olevilla mittareilla. Niitä mitataan satelliitista, säteilymittareilla. Ja tämä on sitten NASAn säteily, siis tätä satelliittimittaus. This is a satellite measurement of NASA temperature. This is one visualization of the warming. You can see here blue is from the 19th century, and this is from 20th century onwards. And you can see the nearer we come to the present, the warmer it will get. So it has warmed this 1 degree about. And you can see the winters are warming. The whole year is warming. Okay. This one just visualization of this thing. This is Hardgrut is British. This NASA is of course American. This is British Met Office. Englantiin, niin kuin Britannian ilmatieteen laitoksen konstruktio. by the way, the first kind of a reliable measurements of temperature, they are from 1915 onwards, not before that, because of course the thermometers weren't developed much earlier, the reliable ones. Lämpötilaahan mitataan siis ihan näillä mittareilla, joka perustuu lämpölaajenemiseen tai sitten resistanssiin, siihen sähköjohtavuuteen tai sitten säteilyyn. Ja nämä oli tietenkin lämpölaajenemiseen nämä ensimmäiset, niin kuin meidän tavalliset kuumemittarit tai lämpömittarit. Here you can see the temperatures. They are rising. They are rising. And we hit the records all the time. The last year, 21, it was the 7th warmest on record, the whole globe. But it's all the time we are hitting the records, year after year. 21 was so-called La Nina year, which means that we have this international variability of temperature because of the sea currents. The sea is really controlling the temperature because 70% of the globe is sea. And there's a lot of potential warmth and cold in the sea. So when the sea currents, the winds change a bit from year to year, and then you can get different kind of temperatures in land and the globe. But the sea is warming, the land is warming, and you can see it going up. But it's not steady, but it goes like seesaw. Jigsaw. Elikkä meret määrää aika paljon sitä niin kuin sen tietyn vuoden lämpötilaa, mutta se koko ajan lämpee. Koko ajan lämpee, että jos meren sieltä syvältä tulee kyllä viilempää vettä, niin se voi vähäksi aikaa viilentää, mutta se koko ajan se menee ylöspäin. Ocean heat, elikkä meret lämpee koko ajan. Mulla ei ole tässä nyt semmoista, mikä näyttää syvällä ja sitten pinnassa oleva lämpötila, mutta sekä syvällä lämpenee että pinnalla lämpenee. So oceans are heating from the surface and from the bottom. But it takes time the deep water to warm up. But when the oceans, this is a prediction, when the oceans have warmed from the surface to the bottom, we will see perhaps in a steep rise of the temperature, because it's cooling. The seas are now cooling. They are taking the CO2 and they are cooling. They are taking most of the heat, actually the seas. But when the seas have warmed enough, they will start to really warm the earth. Sea level, here you can see it's the sea level. From the reliable measurements are from the beginning of the 1990, and the sea level is going up. Now it's about 4 millimeters per year. This is about the same than the land is getting up in Turku area, in the southern, let's say, southwestern Finland. The land is getting up about 4 millimeters per year because of the ice age. You remember the ice age thing. But now the sea is getting up globally about 4 millimeters every year. So, as you remember, the people are living. Most of the people on Earth, they are living by sea, in cities and by sea anyway. So now the sea has raised 20 centimeters at least, 20 to 30 centimeters Eli meri on noussut nyt tänä historiallisena aikana 20-30 senttiä ja se tulee sitten nousemaan vielä vaikka kuinka paljon. When it was as much CO2 in the atmosphere and when it was as warm as it is now, we have to go back 130,000 years. So back to the previous interglacial, the warm period. So we have to go back there so long time when it was as warm as it now, and we have to go back that 3 million years to go back there where the CO2 in the atmosphere was the same than now. The sea level during the last interglacial 130,000 years ago, the sea level, if I remember it right, it was more than 2 meters higher. So the sea level is going to rise whatever we do. If we stop all the CO2 and other greenhouse gas emissions, the sea level will rise many meters still, whatever we do. But it takes time. The sea level rises mainly because of two things. Ice is melting, ice caps, land ice, and the expansion of the water. The warmer water takes more room. Elikkä lämpölaajeneminen ja sitten jäätiköiden sulaminen. Merijään sulaminen ei vaikuta tietenkään, koska se kelluu, sehän poistaa itsensä määrän vettä. Eli merijää ei nosta, vaan maalla oleva jää. Jäätiköt, Grönlanti ennen kaikkea, mutta Länsi-Antarktinen, Etelämantereella ja sitten vuoristojäätiköt, ne nostaa merevettä tällä. Tässä on jäätiköistä, eli tässä on kaikki maapallon jäätiköt mitattuna, että kuinka paljon ne menettää massaa. How much mass the ice caps and glaciers are losing. So there are only just few glaciers that are expanding. Most are retreating. They are losing mass and at accelerating rate. So this is Arctic Sea. Arctic Sea. There's no Arctic pole is just open sea. Okay. There's Greenland, which is kind of it's not an landmass. How to say? Yhtenäinen, unified landmass. It's a kind of an archipelago actually, Greenland. When it melts, we'll see a huge sea inside Greenland. So, but polar ice is not. There's no land. It's on ocean, and it's melting fast. During winter times, it's going to be ice for probably tens of thousands from now. There will be ice during winter, but during summer it's going to be less and less, and it's predicted, calculated that 2050 there won't be any ice during the summer in this polar area. No ice 2050 during summer. So that means in the end of summer, September. Then there's the minimum. amount of ice. September, there will be no ice. So even now they are making routes. They are carrying. There are ships going from Europe to Asia during summer. Russia is waiting for that. Really. Those bastards. Yeah. So you can watch this. You can see. We'll see which will be the exact year when the summer ice is gone. It might be during my lifetime. It definitely should be during your lifetime. Yeah. Okay. These are some of the graphs we should watch. But unfortunately, it's not a very pleasant thing to watch them, and there's no news because they are just going. CO2 is going up, temperature is going up, ice, glaciers are melting, they are going down, summer ice is going down, and so on. I've seen it. I watched it 20 years. No news anymore. Okay, we take a break.